Hey everyone, Teacher Chang here, and today we're going to take a look at measures of arcs and the arc lengths in a circle. So let's go ahead and first take a look at the measures of our arcs. So when we have a minor arc or a semicircle, the measure of the arc is going to be the same exact thing as the measure of the central angle. So we can see in this quick example here that we have a central angle of AOB at 120 degrees. And we can also see that the arc from A to B right over here is that same exact angle. So we can say that the measure of our arc is going to be 120 degrees. So it's the same thing as our central angle. So with that in mind, let's go ahead and take a look at this quick example here. So what we have is a circle with the center M, and it creates we have all these angles within them, and they gave us some angle measurements in terms of their central angle, which means the corresponding arcs will also be the same measurement. So we could take a look at angle AMB. Well, that's 30 degrees, which means arc AB is also 30 degrees. And I'm just going to go ahead and go around. So that means this is 70 degrees, this is 80 degrees, and well, this is 20 degrees. Now the one that's missing is angle AMF. Well, we do know that a full circle is 360 degrees, and you could do the math and figure out, well, what is 360 minus the rest of these angle measurements, and it turns out to be 160 degrees. So now with all of this in mind, I should be able to find out the angle measurements for each of these arcs. So if I take a look at the first one, we want arc AC. Well, arc AC is from here to here. So we want to go from A to C. Well, arc AC has the 30 and the 70, which totals out to be 100 degrees. Now DF is also pretty simple. So from D to F, that's this one right over here, and that's only 20 degrees. So that's as is. But then we go ahead and take a look at angle ADC. Now remember, we got to start at angle A and we want to end at point C. So we're starting at point A. I should say point A, not angle A. So we're starting at point A and we want to end at point C. So, and somewhere in the middle, we want that D in the middle. So what we're going to do is we're going to start off over here and we're going to go around to D. And then once we hit D, we got to continue that arc all the way around to C. So we're going from A to D to C. Now, if we went the other way, we're not going to have D in the middle. C would end up being in the middle. So we don't want to go the other direction. Okay, so we could either add up 160, 20, and 80, and that'll get us our answer. Or we could go ahead and take 360 minus these two other angles, so minus 100, and that's going to tell us the arc measurement of ADC. So that's going to give us a total of 260 degrees. Again, you could do it in two ways. We could add the 160, the 20, and the 80, and that's going to add up to 260. Or we could take the full circle, 360 degrees, and subtract the 30 and the 70, leaving us with 260 degrees as well. All right, let's go ahead and try that last one. The last one is F to B to C. So I'm starting at point F. I need to go to point B and then C. So the question is, which direction should I go? Should I go to the left or to the right? Well, I got to go to the left because I got to go to B first before I go to C. So if I go to the left, I hit point B, and then I go over to point C. If I went to the right, I'm going to hit C first. So we want our beginning point to be F, our ending point to be C, and we want B somewhere in the middle. And again, we could do the same thing. We could go ahead and add up, starting off with point F to A, that's 160, and then we have our 30, and then we have our 70. We could add those up together, or we could go ahead and once again take 360 and minus these two angles, the 20 and the 80, and that turns out to be 260 degrees as well. Okay, so that's basically the measures of our arcs. Now let's take a look at our arc length. Now the arc length has this formula where we have the measure in terms of our degrees divided by 360 degrees times 2 pi r. Well, what does that mean? Well, that basically means that, well, we have our measure over 360. Well, that's a fraction. So this is a fraction. And that 2 pi r, well, we've seen that before. We've heard of that. 2 pi r represents our circumference. So what we want to do is we're going to take a fraction of our circumference. Now remember, the circumference can also be written as pi d. So you can, if you're given the diameter, you can replace that 2 pi r with pi d instead. So here we have a quick example, and we got that same circle that we had earlier, and we have 120 degrees as our angle measurement. Okay, and that's the central angle, or we could use it in terms of the measure of our arc. So what we want to do is I want to know, okay, well, what is the length? Okay, not the angle measurement, not in degrees. We want to know what is the length from A to B. So from here to here. In other words, if I took a piece of string and I wrapped it around from A to B and then I straightened it out, that's the length that I want. So what we're going to do is we're going to go ahead and take a fraction of our circumference, because that's the point going around it. Well, that angle measurement we have is 120 degrees. So I'm going to write this out. So our arc length is going to equal to our 120 degrees out of 360, because there's 360 degrees in a circle. So there's our fraction. And we're going to multiply it by 2 pi r. Well, what is r? R in this case happens to be 8 inches. So we're going to multiply it by 2 times pi times 8 inches. Okay, so all I did is I just substitute my information in here. Now, if we went ahead and kind of did the math here, we know that 120 over 360, if you simplify that, that turns out to be 1/3. So now we got 1/3, and 2 times pi times 8 is going to be 16 pi. And if we were to write this out in terms of pi, our answer would be 16 pi over 3. Okay, so that's in terms of pi. Now, depending on your teacher, some teachers will have you guys leave it in pi form, while others may ask you to go ahead and write it in decimal form. And well, I'm going to write it in decimal form because it asks us to round it to the nearest tenth. So that's a big clue telling me that we're going to round it in terms of a decimal. So we're going to round it to the nearest tenth, and that's going to give us about 16.8. Now remember, it was 8 inches to begin with, so don't forget your label in terms of inches. So our answer is going to be 16.8 inches, and if your teacher wants you to leave it in pi form, it'd be 16 pi over 3 inches. All right, let's go ahead and take a look at another problem here. And this one, very similar to what we have here. But instead, they gave us not the radius, but they gave us the diameter. So they told us the diameter is MT. And since I know that we have a diameter here, I'm going to change up that formula in terms of the arc length. So the arc length is still the fraction of our circle, so that means some measurement in terms of degrees divided by 360, so that's the measurement of our circle. And then since I'm talking about a diameter here, instead of 2 pi r, I'm going to do pi d. So it's the same thing. Remember, it's a fraction of your circumference. Okay, so let's take a look at this first one over here. They're asking us to figure out, okay, what is the arc length of NR? Now, if I take a look at our NR, well, that has a central angle of 29 degrees. So that's going to be my angle measurement. So that's 29 out of 360. And then we're going to multiply it by pi times d. And d, we said earlier, is 15. So I'm going to multiply it by 15. Okay, so now all we got to do is the math here. And if we multiply all of this together in pi form, if you simplified it all, it ends up being 29 pi over 24. And if you decide to go ahead and rewrite this in terms of decimal form, well, that's going to be about 1.2. In this case, we'll say units because they didn't give us a unit of measurement. So 1.2 units. Okay. I'm going to do the same thing for this next one. So this next one, I'm going to go ahead and take a look at TSR. So it's going from T to S to R. So if I take a look at that, if I trace it around, so T, oops, let me go ahead and change that back. So T to S and all the way down to R. So I got to go to S before I go to R. So that's this entire piece over here. And we got to remember that, well, semicircle is 180 degrees. So I could go ahead and add 180 with the 51 and the 29, and that's going to give me 260 degrees. Okay, so what we have here is 260 degrees. for TSR, I'm going to substitute that in as my angle measurement, so 260 over 360. And then we could go ahead and multiply it by our diameter, so that's just pi times 15, or we could say 15 pi. And if you did the math here, it ends up being 65 pi over 6. And that's in terms of pi. But if you want to write it in decimal form, that's about 30.03. So we'll just go ahead and write down 30.0 if we want to round it to the nearest tenth. So that's going to give us 30.0 units. So that's our unit of measurement. All right, we got another problem, which is slightly different here. This time, what we're looking for is the radius. So we don't know what the radius is, but they did give us the circumference, or the part of our circumference. So they gave us our arc length, which is this part over here. That's 32 pi. And they also gave us the central angle at 80 degrees. So what we're going to do is we're going to use our rule here, and I'm going to write out that rule. It was the arc length is equal to the measure of our angle over 360 times the circumference, and since we're finding radius, I'm going to do 2 pi r. Okay, so all I'm going to do is I'm going to substitute everything I know. So we do know that the arc length is 32 pi. And that's going to equal to our measure of our angle, which is 80 degrees. So I'm going to put that over 360. And then we're going to multiply that by 2 pi r. Okay. So what we're going to do here is, what's making this problem a little bit more difficult to see or understand is that fraction. A lot of people don't like fractions, so I'm going to get rid of this 80 over 360. Well, to get rid of that fraction, I'm going to multiply by its reciprocal. So I'm going to multiply by 360 over 80. So I multiply both sides by 360 over 80. What I do on one side, I do to the other. And that way, the 360 and the 80s will cancel out on the right. Okay, so the 360s cancel each other out, the 80s cancel each other out. And now I got 360 over 80 times 32 pi. And if you calculate all of that, that ends up being 144 pi is now equal to 2 pi r. Okay, so you could do 360 times 32 divided by 80, and that's going to give you 144. And we still have that pi. So now, again, I want to get r by itself. My goal is to solve for pi, or solve for r. So I'm going to go ahead and get rid of this 2 pi by dividing both sides by 2 pi. And from here, we can cancel out the pi's. And all I got to do is divide 144 by 2. And 144 divided by 2 is going to give me 72. And then I look for my unit of measurement, which I don't have. So we'll go ahead and call it 72 units. All right, so that's how you go ahead and find the missing radius. Now, other times we might be missing the central angle. So in this particular case, we do have our radius and we do have our arc length. So the arc length is 4 pi, and the radius in this case is 48. So we know what the radius is. So again, I'm going to go ahead and just substitute everything into our rule. So once again, the rule is the arc length is equal to the measure of our angle over 360. And then we're going to multiply that by 2 pi r. And all we got to do is substitute. So if I substitute everything in, so we do know that the arc length is 4 pi. And then we don't know what that measure of our angle is, so I'm going to leave that as m. And then we have our 360. And then we have our 2 times pi times r, and I'll just go ahead and write that out. 2 times pi, and r in this case is 48. Okay, I'll close up the parentheses here. Okay, so now we just got to do the math. We're going to simplify this a bit. So if I wrote this all out, we now have 4 pi is now equal to the measure of our angle over 360, and 2 times pi times 48 is going to give me 96 pi. Okay, so what we want to do is, if we combine those two together, if I want to rewrite this, this is really the same thing as 4 pi is equal to 96 pi m, which we're missing over 360. So now we could go ahead and get rid of that 96 pi and the 360. And we could do that at the same time. It's kind of like a fraction. So I'm going to multiply both sides by the reciprocal. So 360 over 96 pi. Okay, so now we can cancel out the 96 pi, the 360. And then on the other side, we can cancel out the pi's. So now we're left with m, which is our angle measurement. Oops, let's fix that. That's our angle measurement. So the measure angle here is going to be 360 divided by 96 times 4, and that turns out to be 15 degrees. All right, so now what we've done here is we've talked about how do we calculate for a central angle. We've calculated for the arc length. We calculated for the radius. And these are all the things in terms of arcs that you need to know for the circle. All right, I hope this helped out. If you have any questions, go ahead and leave a comment. Don't forget to like this video and subscribe. All right, good luck, enjoy, and have fun.